Hello students, this is Dr. Munir Umar with CS222 Database Management System. Today in lecture number 37, we will study about anomalies in DBMS. This topic can also be called as data anomalies or database anomalies. So this is the agenda of today's lecture. First, we will study about the redundancy. By redundancy, we mean the repetition of data in a database. This could be in a single table or in multiple tables. Then we have the definition of database anomalies or data anomalies. Actually, by anomalies, we mean that the abnormalities of data inside a database. Then we have three types of anomalies. These are update anomalies, delete anomalies, and insert anomalies. We will study about these types in details with some examples and will also do practice these examples in our MySQL workbench. Okay, first redundancy. By redundancy, we mean the duplication of data, or simply you can say that when records are repeated in a database, then that case is called redundancy. Data redundancy is a condition created within a database. Actually, when there is repetition of data, then we can say that it is a kind of condition in the database, and that condition is called data redundancy. In data redundancy, each piece of data is held in two or more separate places. Suppose we have student record, so the name of the student is stored in two or more tables. So in that case, we can assume that the data is in redundant form due to its repetition. This can mean two or more different fields within a single database. Whenever data is repeated, this basically constitutes data redundancy. This can occur by accident or by poor database design. Mainly, the redundancy is caused due to the poor database design. So, during the design phase, we must consider this thing and we must try to avoid such type of repetitions in database. This is an example of redundancy. Here we have some tuples about the student. These are under student ID, name, program, department, and department HOD. So in this table, we have actually two things. The first thing is about the student and the association of student with the department. So we have also some data about the department. Now, if you look into this table, these things are correct because these are associated with the student and we cannot um, design in more efficient way so that these can be reduced because these all are not repeated. But if you look into the department and department HOD, these things are repeated. Like here, for three students, this department HOD is repeated. Similarly, for these two, we have repetition and also here we have repetition. So, such type of repetitions are called data redundancy in database. These repetitions actually violate the data consistency during the operations on database. We can eliminate this redundancy from this table by making or decomposing this table into two separate tables. Here we actually deleted these two columns from student table and created a new column for department. Now This department ID can be used here in this table so that we may connect these two tables. And in this way, these values will not be repeated, and also these will be connected with this student table. Now we have database anomalies. Anomalies are caused when there is too much redundancy in the database. Actually, by anomaly, we mean the abnormal situation. During operations, we may face some issues associated with the records. So, actually, those issues are due to the data redundancy, and that situation is due to database anomalies. Anomalies can often be caused when the tables that make up the database suffer from poor construction. As I told you that the redundancy is caused due to the poor database design. If the tables in a database are constructed in a poor way, they are not properly designed, there is a redundancy in the database tables, then in that case we may face anomalies. To avoid the anomalies, we go through the normalization. Normalization is a process in which we decompose different tables so that we may reduce the redundancy of data in the database. So, the normalization process was created largely in order to reduce the negative effect of creating tables that will introduce anomalies into the database. We have three types of anomalies. The first one is update anomaly, second one is delete anomaly, and the third one is insert anomaly. So first we have update anomaly. It is associated with the update of data. Whenever we update some data in the database, so the data must be in a consistent form after the updation process. So the update anomaly exists when one or more instances of duplicated data is updated but not all. So if you are going to update something in the database, then you must make sure that there is no redundancy. And in case there is redundancy in the database, then you must update all the repeated records in the database. Consider this table. Here we have some repeated records in the table. So these all are repeating. Now, suppose I'm going to change the name of HOD of IIT. So, I must make sure that these three names must be updated. Now, for this purpose, usually we use update queries, and in update queries we use the primary key for identification of data in the where class. So uh, in that case, if you are going to execute a single query with a single condition in the where class, so in that case only one record will be updated. Now I'm going to change the record of this student. I'm going to change the department HOD for this student. It will be changed with an update query, but the rest will be remained as same. So in that case, there would be data inconsistency. For one record, we will have different name for IIT HOD, and for the rest, the name would be different. Let's check this update anomaly in our MySQL workbench. Here we have a database. Its name is student. You can see This database name is student. It has some tables. It is actually one table. According to our slide, its name is std-info and it has some columns in it. So we are going to change this. Actually, we are going to change a record in this table to demonstrate the update anomaly. So here we need to check the contents of this table. So first we need to use this database. Its name is student. This has been selected. Now select some records, sorry, all the records from this student table. Its name is std-info. It should be small. Select static from std-info, control enter, execute it. Should be from, control enter. So here we got the records from this table. Now if you look into these records, these all are repeated. Now here we have three repetitions, 2 and 2. So all the tuples have some repeated data. Now suppose we are going to change a record. Let's say we are going to change this one. So actually we are going to change the name of department HOD for IIT, and we are using this tuple. So what will happen, this single record will be updated and the rest will be not updated, they will remain the same. So that is actually the situation of update anomaly. So we are going to have an update query on this tuple. So here I'm going to type update, then the table name, it is std-info, then set the column name is dept underscore HOD. So we are using this thing. So here I must type department HOD, and I'm going to give a new value to this tuple under department HOD. So here let's say I'm changing it to Han, and after that I must give the where clause, where the SID, we are using SID instead of this thing because now it is in safe mode. By default the DBMS will never allow us to use any other attribute instead of primary key for update and delete queries. So here the SID is the attribute name. SID equals CS123454, and this is a string, it must be enclosed in single quotes. Now execute it, control enter. This one got executed, and if you look into the record now by using the select statement, you will have this department HOD changed, but the rest are same as previous. So what happened, the department HOD has some inconsistent data. So if you look into these values, you cannot get the exact name of the head of the IIT department from this table. So this is actually an update anomaly. This is an issue in our records, and we can also call it inconsistent form of data. Next we have delete anomaly. Delete anomaly exists when certain attributes are lost because of the deletion of other attributes. Now consider this table. Here in this table I can get the name of header of mathematics department. So these two values can show me the math department along with its HOD, and also I can get the location of math department. Now I'm going to delete this student from the database. Let's say this student left the institute and we are going to delete its record. So what will we do? We will execute a delete query on this tuple. But what will happen? The additional data about department will also be deleted. Our intention is to delete this CS712 Nazir only, and this is not our intention to delete the record or the data about the department. But unfortunately, when we execute this query on this tuple, the entire tuple will be deleted. The record about department will also be deleted, which we may need in future. So this is the case of delete anomaly. Here in this table, we have some records. The last tuple in this table shows us the information about math department. So I can get the name of the head of math department from this last tuple. And let's say I'm going to delete this student from our database by using a delete query. What will happen? This entire record will be deleted. I can get the HOD of this department by using a select department HOD from the table name is std info, where the department is maths department. So here, when we execute this query, we will get the name of the math department HOD. It's student info. Control enter. Now we got the name of the math department HOD. It is displayed here. You can look into this. Now I'm going to delete this student from the table. So I must type a delete query. Delete from, the table name is std info, where the attribute name is sid equals to cs. It is 323454 and it should be enclosed in single quotes. Now control enter. This one got executed, and if we execute this query, we will not find the department HOD. Now here in this table there is no record about math department. Similarly, if we need to get the department HOD from student info, where department is equal to math department, we will also get null, because there would be no record. So there is no record about math department. So the entire tuple has been deleted instead of the student name due to this delete query, and our intention was to delete the student name only, not the record about the department. So this case is also causing the data loss, and this case is under the delete anomaly. The last type of anomaly is insert anomaly. Actually, this type of anomaly is the inverse of delete anomaly. In delete anomaly, we deleted the entire tuple and lost some important data, which we didn't want to be deleted, but due to deletion of some record, some additional data was also deleted. Now, in insert anomaly, suppose we are going to enter something in the table, but we don't have the all the values for attributes. So in that case, the data will not be inserted. The insert anomaly occurs when certain attributes cannot be inserted into the database without the presence of other attributes. So consider this table. Here we are going to insert data about the department. We are going to insert the department name, then department HOD and location of the department. But we don't have the student information. Like it is a situation when there is no student in the department, but we are going to create a department. So this would not be possible for our designed table. We will not be able to add such type of data in our database. So this case is actually insert anomaly. We must need a student to be enrolled first in the department, and after that we will be able to put some data in the tuple in this database table. Now here in this table we are going to add the information about math department. So for that purpose we must use an insert query. So I'm typing here insert into table name is std info, and then the attributes are, we don't have the information about student. We are going to insert the last three attributes only. Those are about the department. So here I'm going to insert, let's say, the last two attributes. We are going to insert the last two attributes about department. So I must type DEPT and then DEPT underscore HOD values. Values are, let's say, math department, and name is, let's say, new HOD. Now if we execute this query, it will give us an error due to the lack of attributes. Particularly, there is no primary key in this insert query, so it will give us error. Execute it. Now if you look into the output, you will get an error. So here we have error for this query. Primary key is not given. So this is the case of insert anomaly. Without complete information, we cannot add partial information to the database table. So in today's lecture, we studied about the redundancy. By redundancy, we mean the repetition of data. Then database anomalies. By database anomalies, we mean the abnormalities in database, particularly the issues when we face with some database operations. Those are referred to database anomalies. Then there are three types of database anomalies: the update anomalies, or delete anomalies, and insert anomalies. We studied about all these and checked these in our MySQL workbench. We also checked some examples in our lecture. Our next lecture is about the functional dependencies in databases. Actually, we are moving toward the normalization. So once we complete the functional dependencies, after that we will move to the normalization process in the DBMS. This is very important topic, and we will discuss this normalization in details. So far, this lecture has been over. If you have any question, you can put your comments in the KCMS. I'm hopeful, and I think you will do practice these all by yourselves. Thank you.